Example 22.5 says to write the first four terms of the sequence whose nth term is, and we have a sequence defined for us. So notice that there is a factorial symbol in this, and the factorial operator is a really fun operator to work with, and I don't want you to feel like I've been hiding it from you all semester long. There's just never been an appropriate time to bring it up until now, because all of the other functions that we've dealt with have had domains that involved fractions and decimals and irrational numbers, all kinds of things, all kinds of real numbers were allowed. But for a sequence, you're only allowed to plug in natural numbers. And since the factorial only likes integers, positive integers, I should say, this is the right time for us to introduce it. So you'll notice that this operator can only show up here in a sequence. So let's start with calculating A1. A1 will be 20 divided by 1 plus 1 factorial. And this would also be a good time to discuss the order of operations. And I suspect that a large majority of us are going to be familiar with the idea of PEMDAS. This is a pretty typical way for the orders of operation to be taught in the public schools around the country. And the factorial is going to fit in line with the exponent operator. It's going to be up here on that kind of level in terms of the importance. So when it comes to looking at this, what I will not be allowed to do is apply the factorial to each individual value in the parenthesis. So I cannot say 1 factorial plus 1 factorial. That is not allowed. I'm going to cross that out. You can't do that. So instead, we have to follow the parenthesis guideline, which says perform whatever operation would be inside the parenthesis. So this is going to become 20 divided by 2 factorial. So once I add 1 plus 1 together, there really is no need to keep that parenthesis because the factorial is now going to be applied to that 2, and we know that 2 factorial is 2, and therefore we get 10 for the first term. Now let's do this for A2. That'll be 20 divided by 2 plus 1 factorial. So that's going to be 20 divided by 3 factorial. So that's 20 divided by 3 times 2 times 1. And 20 could be written, instead of 20, I could write it as factors 2 times 10, and then 3 times 2 times 1, I'm just going to make it 3 times 2. The multiplying by 1 there, while that is part of the definition of the factorial, is not exactly all that necessary because multiplying by 1 is not going to change the value of the expression. More importantly though, when I take 20 and write it as 2 times 10, it allows me to be able to cancel the like factors of 2, and therefore I get the simplified fraction 10/3. Keeps me from having to use a calculator and decimals to simplify the fraction there. So let's see that again with A3. So with A3 I have 20 divided by 3 plus 1 factorial. So that's going to be 20 divided by 4 factorial. So with the 4 factorial, I'm going to think of this as 4 times 3 times 2 times 1. And 20, rather than thinking of it as 2 times 10, I can factor it differently as 4 times 5. So the reason for doing that is it allows me to be able to cancel the largest factor from the denominator, taking me into the most simplified answer right out of the gate. So I have a 5 in the numerator, and then 6 in the denominator, and then 5, 6 would be the simplified answer there for the third term. And we'll do this one more time. A4 will be 20 divided by 4 plus 1 factorial. So that's going to be 20 divided by 5 factorial. 5 factorial, 5 times 4 times 3 times 2 times 1, and then 20 I'm going to write again as 4 times 5, and this time I conveniently get the 5 and the 4 to cancel, so my denominator is still going to be 6 with the 3 times 2 times 1, and then when all the factors from the numerator cancel, there is still a factor of 1 that's there, and so I end up getting 1/6. So our final result will be 10, 10 thirds, 5/6, 1/6, and that's going to represent the first 4 terms of this sequence involving a factorial.